Stacking up the paper, yeah, the grind will never stop from the...
Okay, let's look at problem number 1 here. It says, which system is shown by the graph? So one of the things that we have to pay attention to is that value there. That's the only one they give us. So what I would do is type in the first equation of each of the systems. And so what we're looking for is to see, does this line go through the 0.80? It doesn't. So I'm going to go back and I'm going to change the equation and see if it goes through the 0.80. That doesn't. Okay, so now we're going to try the third equation. I got 4x minus 10y equals 32. That goes through 8, but it goes through in the wrong direction. So we know that the answer has to be answer D, the only graph that goes through there. So that just took less than a minute to figure out. We don't have to substitute any values. What you would find is if you substituted 8 in for x, that both of these would actually work. But the problem is you have to find a second point that would work, and that creates an issue. So the graphing method for this problem is by far recommended for you. All right, let's try this problem here. Okay, so this one, there is a way to do it on the graph, but the easiest thing to do is if we look here, because both of these have 8x and both of these have 7y, we can substitute and recreate this equation and just call it 2x plus 4y equals 12 and negative 2x plus 4y equals 12. Now, you can solve it if you want and then substitute it back in. I like to just be sure and use Desmos. So we're going to type this in and get our solution, and then we're going to substitute those values in for 8x plus 7y. So let's take a look and see what we get. All right, and we get this value of 0 and 3. So x equals 0, y equals 3. What is 8x? 8 times 0 plus 7 times 3. All right, and we have our answer. All right, let's go to the next problem. All right, another systems problem here. Since they're all systems, we're going to take a look at this one here. So we got 3x equals 36y minus 45. All right, and the key word is that it has no solution. So remember, no solution means the lines are parallel to each other. Okay, so they don't intersect. So what we're looking for is equations where they don't touch. So here's the first one, 4y. All right, and we see that the first answer intersects. So let's get rid of that choice. The next one, okay, the next answer choice, okay, is that parallel? That's the question. Is it parallel? So we can look at this in a couple different ways. We'll find that this is 0, 0. And this one here is 0 and 1.25. And we can look at different points here. So if this is not quite that. So that's possibility for 2 to see if it's parallel, but let's just double check the other ones here. Okay, and we see that answer choice C is the exact same line, so that's not what we want. So let's try answer choice D just to verify that we didn't miss anything here. Okay, and we see that that intersects. So we know that the answer choice was, in fact, B, in this case, the one that 1/3 x equals 4y. So just to show you again, there's our two lines, and if we zoom out, we'll see that they're parallel for a very long distance. Okay, so that's the way to do that. You could have done some algebra ways, but I like to try to show you guys shortcuts without having to actually know the math so that you can actually get points on this test and score as high as you can. Okay, this one is definitely, it looks like a headache, but it's really not. So what we're going to do is we're going to, again, graph the equations. Okay, so there's our first equation, and then we're going to graph the second one. Whoa, what a mess that problem was. Okay, here we go. We got it under control. Okay, so what happens in this case is we have a slider that pops up, and we're going to want that slider. So as soon as we see it, we're going to hit add slider, but now we need to come up and finish the equation. Sometimes Desmos is a little touchy, so it doesn't. Anyway, just do it like I showed you. It's one of the easiest ways. So what we want to do now is just move this thing until it is parallel. So at what value is it parallel? That's definitely not parallel. And most times the value is going to be an integer number. And here we have the value of 6, which is going to make that parallel. So one way to test it is we could look at the intersections. So the distance between negative 0.5 and 0.22 is going to be a distance of 0.72. So if it's parallel, then that should mean that at 0.60, this should be a distance of 0.72 at 6, which it is right there. It's hard to see, but you can see it. So we know that the value has to be 6 in this problem. Okay, let's go to the next one. Okay, the next one we can graph, but this one would be an algebra problem that it's going to be a little bit easier. So they intersect, so we know that there's one solution, and they give us a value for x here is 4. So what we're going to do is we're going to take that 4 and substitute it here. So we end up with 4a plus by equals 72. And then we're going to take that x and we're going to substitute it down here. And so we end up with 24 plus 2 by equals to 56. All right, so to get 2 by, we're going to subtract 24 from both sides. And so we end up with 2 by equals to 32. So what does by equal to? 16. Now I know that seems weird, but if we look back up here, what do we notice? We have a by term. So we have 4a plus 16 equals 72. And now we can solve for a in this case. So we end up with 56, and then a is going to be 14. So there is a Desmos way. It is a little bit wonky. At this point, since these are hard questions, you should have some knowledge of math to get this far. If you want this example with Desmos, comment in the video below, and I'll be sure to show you how to do this one in Desmos in a future video. But that's how we're going to do it today, is by hand. Okay, this one has 2 different constants, and it says infinitely many solutions. So we know that they have the same slope, and they have different y-intercepts. But what is key here is they have to have the same slope. So if we look here, they have g divided by k. Okay, so we're dividing the first value by the second value. And if they're parallel, they have to have those same values too. So what we're going to do is take 2/5, because that is the g value, divided by 7/5, and we get an answer of 2/7. So that looks really challenging. There's lots of distractions, but that is going to be your final answer. So if you take g divided by k, it has to equal to 2/7, whatever g and k is. Okay, next problem. Okay. All right, so we have this idea of r, and if you look at the answers, this looks really confusing. So what they really did is just swap out x and y. They substituted r for x and y. So it looks confusing, but it's really not. And it's a system of equations. And it's pretty easy to see that if we multiply by 4, these are the exact same line. Okay? So all we're going to do is take this equation and substitute r in. So if x equals r, what happens? So I have 7r plus 6y equals 5. So we're going to solve for y in this case. So when x is r, what is y equal to? So that is going to be checking these answers right here. Does this actually work? If x is r, is it one of these two? And so we get 6y equals negative 7r plus 5. We're going to divide by 6. And we find out y is equal to negative 7r over 6 plus 5/6. Okay, and so what do we have here? Do we have that answer in our choices? And we do not, because we have this negative 7r instead of a positive 7r. So what happens if y is equal to r then? If y equals r, we're going to do the same thing. So 7x plus 6r equals 5. We're going to solve for x. So 7x equals negative 6r plus 5. X equals negative 6r over 7 plus 5/7. So what we're looking for, do we have an x value of this? And we do. This x value is going to be here when y is r. And so that's going to be our answer for that problem. So it looks really confusing, but if you just realize what you have to do. So if you see a couple more of these practice ones, I have some practice sets on Teachers Pay Teachers, and there's a few more that are like this that you can practice. It's really just substituting. It's a fancy way to substitute in the systems of equations. So definitely a hard problem, but once you see it explained, it definitely can be tackled. So, okay, number 8, we have a story problem, a word problem. And this isn't hard at all. So what we're going to do is we're going to say August, all right, is going to equal to y in this case. You'll see y in a second. And September is going to equal to x. So in August, okay, we have 3 times as many as September plus 15. So 3 times the number of sales and 15 more. So that's what August is equal to. And then September is just equal to x. So that's where we get our 2 values. Now, we're going to use this equation, okay, but we're also going to find out that how many total sales were there in those 2 months. There was 363 sales. So from that word problem, we've now created our system of equation, and we can solve it. So you can do it by hand if you want. You know me, I love my Desmos. So I'm going to substitute these values in and see what we get. All right, so on my screen, we don't see it. There it is, way up there. When we touch it, we get x equals to 87 and y equals to 276. So how many sales were in September? So we have to be careful. That's the value we're looking for, is the x value, because that's what we set September to be. So you could have switched the variables up if you wanted to. This is just how I did it. And you could do this pretty quick, but you do have to know how to set up the equation. Let Desmos do all the heavy lifting for you. Okay, problem 9. All right, so this one is a little bit tricky here, but it's not too hard. So it's a rate problem. She ran R miles, okay, at 5 miles per hour. So it's kind of a weird setup, but you'll see how this works. All right, and then she biked 10 miles per hour. So we have these 2 fractions, and it tells us she biked a total of 200. So we know that R plus B is going to be 200 in this case. So what happens here is it gives us that she biked twice as many hours as she ran. So we're going to double twice as many hours as she ran equals what she biked. Okay, so we get 2R over 5 equals B over 10. And what we're trying to solve for is we got to simplify this down a little bit. So if we cross multiply this, we get 10 times 2R over 5 equals B. all of this is going to equal to 4r, which is equal to b. And then we also have our r plus b equals 200. So there is our system of equations. So what do we do with b? We're going to replace it with 4r. So we have r plus 4r equals 200. 5r equals 200. If you wanted to, by the way, we don't have to do this. We could just call this 4x equals y, and x plus y equals 200, and then go ahead and solve it in the calculator. So why don't we do that? You can figure out what that is if you're following along at home. I will give you guys the Desmos version. Okay, and we see the intersection is r is our x value here. So r equals 40, and the bikes equals 160. And so the question asked, what is the total number that she biked? And so we have our answer of 160, which is answer choice D. Now, here's the thing to think about. If I know some people are going to comment, and if you want, comment below and tell me how much you hate the way I did this, but that's okay. If we solve this thing, we get r, which is our x value, is going to be 80, and then 80? No, 40. Holy cow, math teacher. Okay, 40. And then to get the bike, we have to multiply 40 by 4, which gives us the 160. So you can do it. You just have to do that little substitution. If we do it with Desmos, it's already done for us. So, okay, let's take a look at our last question today. And this is a percent problem, and they show up all over the place on the SAT. It's definitely worth knowing how to do it. But you do have to be careful because there is a few little tricks in here that if you've never seen these before, you're definitely going to get caught on one of these. So it says that you have this alloy that's a mass of 50 grams. All right, so we have two metals that's going to give us a total of 50 grams. All right, now the first metal is made up of 30% silicon. So we take 0.3 times our first metal, and the second metal is 80%. And in total, it's going to be 50% of the 50 grams. And so we end up with this as our system of equations. So let's come on over here. Now, out of this problem, this is the hardest part, is setting up the second equation. By far, it's the hardest. But again, once you see these a couple times and you practice them, you'll be all set. So once you learn these little tricks, you're going to be golden and hit that score that you're after on that SAT. So does everything look correct? We look at the intersection. Okay, so x equals 30 and y equals 20. And the question is, what is the second piece? So we're going to use this. Now, what is the second piece? Well, it's 80% of it. So we have to take 0.8 times 20, which gives us 16, which is our answer there. And if you're not careful, guess what the answers are? You can see answer C and answer D. They're waiting for you to say those, but those are definitely not correct. So hopefully this helped. This is a long form tutorial video, so please drop some comments. Tell me what you liked, what you didn't like, what topics you'd like to see. I posted a lot of videos this week on systems of equations, so I thought I would do a long form tutorial video for systems this week for you guys. So this is Kai, the SAT guy, signing off. I'll see you guys next time.